This HST header, as it was known, was drawn by a horse team connected to the front of the machine, and the operator, while sitting on the seat here, he had to steer the front of the machine with this lever here to keep it in line with the crop. This lever here operated the front of the machine up and down for the various heights of the crop, so that he was working that lever all day to control the height of the crop and the material coming into the machine. And when the box filled up, he had a lever over the side here that he had to turn to level the grain in the box. So he was quite busy all day by moving this lever and the arm here and the steering on the front of the machine. On hilly ground, when they stopped the harvester or going down hilly ground so that it wouldn't affect run into the horses, the operator was able to push on this lever to control the speed of the header going forward and not hurt his animals or the machine get away on him. As the machine was being drawn along by the horse team, this big wheel turned, and in turn it turned this big cog in here, and it drove across this shaft which operated all the gears and the chains to work the mechanism of the harvester as it was going along. And they were all in a constant ratio to one another to make the machine work correctly, to clean the wheat and thresh it out and so forth. The crop was cut off by the knife in behind the fingers here, which was unique to the HST header. Earlier harvesters didn't have a knife in them to cut the crop. They used to just strip it off, and that moved backwards and forwards at a big rate of knots to cut the crop off as it was held between the fingers. Then the spiral, the front spiral here, and there's another one at the back. On early machines, that's the back spiral there. On early machines, those spirals were timed so that they didn't hit one another, and that was a pretty unique system. After the crop was cut, it would come across the spirals and up the elevator, this elevator here, and this little butterfly then pushed it back into the threshing cylinder, or the drum as we called it. You can just see the drum down the bottom there. And the drum would thresh the grain on the concave, and then it would go through into the sieves. On each end of the drum there was a fan which produced the air to blow the light material away from the good grain. The good grain would then fall down and come up this elevator here and be delivered into the screen up the top here, and the good grain would go into the grain tank or the grain box here, and the large material that needed to be re-threshed again would come down this chute and go back into the drum to be re-threshed and go through the system again. When the material was threshed in the drum, the straw and all that sort of material would go up over here and inside onto the straw walkers, which would distribute the straw out the back of the header, and the smaller stuff would fall down onto the riddles, or the sieves as we call them, and that's, you can just see part of the sieves there. And those sieves, there's two of them, a large one and a smaller one underneath, so that you've got a nice clean sample. And the idea of that was that this thing here used to shake backwards and forwards crossways and shake the material through the sieves so that you got the nice clean sample. And the good clean grain then would go down the bottom and across the machine and up the elevator and into the grain tank. When the grain box was full of grain, the operator would stop going along, he would get off and he would attach a bag onto a bow that sat around here, a frame. The operator would then open the door and allow the grain to run out the hole here into the bag, and he'd dump the bag up and down with the frame until it was full and nice and tight. And then he would shut the door off and then manually lift the bag around and put it in the heap so that the bag sewer could sew up the bags ready for delivery to the silo. We have here one of the latest rotary machines. The difference in a rotary machine is that on the old machines the drum and everything was crossways in the machine, and on this machine and all the rotary machines now, the drum and the rotor run full length of the machine. The front part of the rotor down here, it does the threshing down there, that section there does the threshing, and from there back the grain and the straw and everything has started to be separated, where it used to be done on the straw walkers of an old header. It is now done in that back section of the header, and it makes the capacity of these new machines just so great compared to the old machines, where the old machines that we looked at earlier would do maybe 300 bushels on a big day. These would do far in excess of that in an hour. So it's made the harvest hugely quick. After the grain leaves the rotor, it then goes down through the sieves and is cleaned by the air from the machine, the wind from the machine, and separated, finally separated, very similar to the old headers in the sieve department, but just the rotor is the big difference in the modern machines. This door here opens up so that the operator can look inside the machine down here to see what material is on his sieves when he stops, to make sure the machine's operating correctly. On the later machines, the sieves are all adjusted from inside the cab. He doesn't have to get out and crawl up the back of the machine and get dusty anymore, and it makes it a lot easier for the operator to adjust his machine. These wires here are the wires that operate a little motor which adjusts the opening on the sieves, and that is all controlled from inside the cabin so that the operator can do it all while going along and get the best sample. Inside the cab, everything is electronically controlled now. We have a dash over here which adjusts the satellite steering on the machine so that the operator only has to steer the machine with the steering wheel to go around an obstruction or to go in a direction over to the truck or whatever. But in the field, it's all operated by the satellite steering. He has a full row of monitors down here that allow him to see what the machine is doing, and to adjust the machine. He can adjust all his settings from all the switches and dials that are down the front of the machine. And to lift the machine up and down the front of the machine, you just move this lever here with a button to lift the front up and down, and to change the speed of the machine going forward, it's only necessary to keep pushing that lever forward or bring it to there and back for reverse. Very, very simple to drive and a heck of a lot easier for the operator.